continuing on with inverses, so they give us a point 3x. Here's the trick with 3x. So if it has the point 1, 1, 2, 3, like this point right here, would you agree with me? It's 1 and up 3. And then this point looks to be like, if x is 2, y is 3/2, right? And then if x is 3, y is 1. So this would be 3, 1. Okay, if you flip-flop these to draw your inverse, and instead of 1, 3, you do 3, 1, oh, that's already on the graph. I want you to look, what happens if you draw the line y equal to x? If it's 3 over x, it's an inverse of itself. Puckett, prove it to me. I don't believe it. Okay. So we have f of x equal to 3 over x. Let's find our inverse. I'm just showing you this so you could believe me. So first thing we do, we change f of x to y. Then we switch x's and y's. So I say x is equal to 3 over y. If you're trying to solve for y, I would like y not to be a fraction. So I'm going to multiply both sides by y. That way this cancels and I have xy equal to 3. Remember, I'm trying to solve for y now, so I just divide both sides by x. So I get y is equal to 3 over x. What? That's what we started with. I know. It's the weirdest thing. It's its own inverse. Alright, so it'll be like the exact same graph on top of itself. Alright, just for fun we did that one. Now let's move on to finding the inverse. Alright, first thing you do is you change f of x to y to find the inverse. Second thing you do is you switch x's and y's. X is equal to 2y plus 3. Next, solve for y. So I scoot the 3 over, x minus 3 equal to 2y. Then divide both sides by 2. So then I get, let's say, y equal to, I just put y first, x minus 3 over 2. Now, they're going to probably say it like this. The inverse is equal to x minus 3 over 2. They might say it like this. You could, after you do it like this, if you wanted to write it like in slope-intercept form, you could do a quick little, I heart math, math hearts me, doing my math correctly. So x over 2 is the same thing as 1/2 x, and negative 3 over 2 is like that. Sometimes they write it like that. This and this are equivalent expressions. We should recognize them as such. Alright, let's look at our next one. This is a little trickier because it's a fraction. So we have y is equal to 2 over 4x plus 1. So first thing we do is we change f of x to y, and now I'm going to switch x's and y's. So I have x is equal to 2 over 4y plus 1. Alright, then the next step is I'm supposed to be solving for y. So sorry, I'm going to move up like to here. To solve for 4y plus 1, I'm trying to solve for y, so to get y by itself, I'd like it not to be the bottom of a fraction because that's annoying. So I'm going to multiply both sides by 4y plus 1. Okay, so that these cancel. So then on the right side I just have a 2 left, and on this side I have 4y plus 1 times x. Okay, I'm supposed to be getting y by itself, so first thing I'll do is divide both sides by x to get rid of the x. So that gives me 4y plus 1 is equal to 2 over x. And then next, I need to get rid of the 1, so I'll subtract 1 from both sides, which will give me 4y is equal to 2 over x minus 1. And then the next step is I need to get rid of the 4 here. So I think what I'll do is I will just multiply both sides by 1/4. Multiply both sides by 1/4, if I could squeeze a 1/4 in there. So 1/4 times 4 cancels. Sorry, this is looking kind of sloppy. I should give myself more room. So y is equal to, this was an equal sign, not a negative. 1/4 times 2, you just multiply straight across, which gives you 2 over 4x And then 1/4 times -1 gives you just -1/4. Would you agree with me that 2 over 4x, well, let's just say we are trying to simplify this a little bit and write it as one fraction instead of two. So to do that, we get a common denominator. Looks like the least common denominator is going to be 4x. So I'd have to multiply numerator and denominator by x, which gives me in the 2 minus x over 4x. And so they would say the inverse of this problem is 2 minus x over 4x. Some of you are saying, but Mrs. Puckett, I think I would like to simplify the 2 over 4. Don't do it. Some of you are thinking, we'd like to cancel the x. Don't do it. Okay, these are attached by subtraction, so you can't just unilaterally split them like that, okay? You could leave it, 2 over 4x is the same thing as 1 over 2x minus 1/4. That is okay, because that's the same as this. This is just with a common denominator, okay? I think your test writes it like this. But let me check real fast. I can't really remember. Yeah, I'm still here. Give me a second. They might just leave it like this. They might just leave it like two separate things. But you should know both. You should understand how to connect them or how to leave them different. There won't be both ways, so you'll just have to choose. All right, next for our inverse, we say y is equal to x minus 2 cubed. And then we switch x's and y's, so I say x is equal to y minus 2 cubed. And then take cube root of both sides, which would give me cube root of x is equal to y minus 2, and then I'll just add 2 this side, so it'll be cube root of x plus 2 is equal to y. Or they're going to write it like this. Inverse of x, instead of y, they're going to write inverse, is equal to the cube root of x plus 2. All right, next we have y equal to x minus, or x plus 1 cubed minus 3. So first step, switch x's and y's. So x is equal to y plus 1 cubed minus 3. And so now I'm trying to solve for y. So I scoot the 3 over, so I have x plus 3 equal to y plus 1 cubed. And to get rid of the cube, I take cube root of both sides. So that gives me y plus 1. We still see? I guess so. Not again. We have y plus 1, that's all that's left, can you take this, is equal to the cube root of x plus 3. And then I'm going to scoot over here. Then you just scoot the 1 over. So you have cube root of x plus 3 minus 1 equal to y. They could put the 1 in the front too if they wanted. And they're going to really write it like this. They're going to say the inverse of x is equal to cube root of x plus 3 minus 1.